So you first want to approach this problem by taking the antiderivative of R of t, since that will give you the displaced gallons, or the number of gallons being used up at a given instant in time. Don't forget to add c, and since it is given that at time t equals 1 hour, 0.75 gallons are already used up, make sure you evaluate the antiderivative of R of t at 1 hour to find c. Once c is found, all that is left to do is to determine the amount of gas depleted after 2 hours. Always be sure to truncate your answer to 3 decimal places and subtract 0.159 to get an answer of 1.952. The answer 1.952, which is actually 1952 when you ignore the decimal place, gets you your combination lock to unlock the next clue. The first multiple choice problem is fairly simple. It evaluates your understanding of the first part of the fundamental theorem of calculus. The antiderivative of the derivative of a particular function just gives you that particular function, so you must evaluate f of 4 minus f of 0 and set it equal to 8. Since f of 4 is what you're trying to find and f of 0 equals 5, it takes simple arithmetic to get an answer of 13. This next problem is trickier. You want to use the y equals menu in your graphing calculator and type in f prime of t minus g prime of t. Once you do this, adjust your window and use the 0 feature from the F5 menu to determine the maximum of 7.888. Next, to determine g of t, take the integral from 1 to 2 of f of t. This is given to be an area of 2, but since the graph shows the shaded region to be below the x-axis, the answer is actually negative 2. For this last multiple choice problem, use the product rule to find h prime of x. Once you do that, plug in 2 for the value of x and refer to the graphs given above. Once you multiply and add all of these values together, you get an answer of 14. In all, the answers come out to be EBBC, which translates to 5223 when you use the key attached to the problem sheet. And this unlocks the lock to the closet.
The first card is relatively simple. At the point 1, 1, you can draw a 45, 45, 90 triangle with legs 1 unit in length. The inverse tangent function can then be used to find theta equal to pi fourths. To solve the next problem, first take the derivative of r equals theta minus sine 2 theta. This comes out to be 1 minus 2 cosine 2 theta. Setting this equal to 0, we find 2 theta must be equal to pi thirds, 2 pi thirds, etc., etc. Dividing out the 2 to isolate theta, we get theta to be pi 6. For the third question, we solved it by using the solve feature on the calculator and our knowledge of polar area. To set up the equation, we wrote out 2 integrals using pi 6 and x as the bounds. The first is the integral of pi 6 to x of 3 squared d theta, and the second is 1/2 of the integral of pi 6 to x of 4 plus 2 sine theta all squared d theta. These added together and set equal to 24.709 in our solve feature gives us 5 pi 6 as the missing bound. To solve the final card, one simply needs to plug the given equation into the solve feature of the calculator. It will then subsequently spit out 2 pi as the answer.
Riemann sums, more specifically the left Riemann sum. This gives an estimate of the integral of time 0 to 15 in this specific problem. To find the left Riemann sum, you would need the width of the rectangle and the height. The width can be found by subtracting the x values, in this case time. The height can be found by using the y values, in this case the velocity. Since this is a left Riemann sum, the last y value, 22, will not be used because the left y value in the last rectangle will be 25.
In order to solve the passcode to the phone, you must solve this problem by finding the equation for the linear approximation to the function. You have to first find the derivative of f of x, which is 3e to the 2x minus 10 plus 6x times e to the 2x minus 10. Afterwards, if you plug 5 into this equation, you get the derivative value to be 33. Also, you solve for the f of x value by plugging in 5 into the f of x, which is 15. When put into point-slope form, the equation is y minus 15 equals 33 times x minus 5. Afterwards, to find the code, the problem asks to plug 10,000 as x. Therefore, the code is 329850.